Hey guys, and welcome back to another video. Chemical reactions often release or absorb heat from the environment, so today we will be looking at a few reactions using an IR camera. This is actually a project I worked on in the McIndoe Research Lab during my first year of university. First, let's take a look at a fractal distillation. I added some ethanol and diethyl ether into the apparatus and began heating. Right away you can see the colder condenser column and the hot plate as it heats up. With further heating, the diethyl ether boils and climbs the fractional column. Once the ether finishes distilling, the ethanol boils and begins climbing the fractional column. This gives an excellent visual of what is occurring during a fractal distillation. Next, a reflux apparatus was set up with some xylenes. As the mixture is heated, the xylenes begin to boil and a solvent front climbs the condenser before stabilizing. Once at a steady reflux, the solvent front is clearly visible in both visible and IR light. It's pretty cool to look at common lab procedures under IR, but what about some actual reactions? Let's start with some endothermic reactions, which absorb heat from the environment as they occur. When ammonium nitrate dissolves in water, the solution becomes very cold, which is why ammonium nitrate is actually used in some instant cold packs. Looking at the reaction under IR, it is evident how quickly the solution temperature drops. Another slightly less endothermic reaction occurs when adding ethyl acetate to hexanes. Next, let's see some exothermic reactions. One fun reaction is when supercooled sodium acetate trihydrate crystallizes. Supercooled liquids are formed when a liquid is cooled below its solidification temperature without freezing. This occurs when there are no nucleation sites for the liquid to begin crystallizing. When a small crystal of sodium acetate trihydrate is added, it provides a nucleation site to initiate crystallization. The crystallization releases latent heat as the compound transitions from a liquid to a solid, which explains the exothermic nature of this reaction. Latent heat is basically the energy released or absorbed when a substance transitions from one state to another. If you think about some ice, it takes a while to melt because energy from the environment is required for the ice to transition from a solid at 0 degrees Celsius to a liquid at 0 degrees Celsius. The latent heat of melting is the energy required for this phase transition to occur. With our sodium acetate, the reverse is happening where latent heat is given off to the environment while solidification occurs. The release of latent heat is especially noticeable with the solidification of supercooled liquids because the transition occurs very quickly. Okay, how about adding water to acid? As a common rule, water should never be added to acid because the dilution of acid is very exothermic and can cause the water to boil and splatter. This is especially true for concentrated acids. Well, the solution definitely gets very hot and exhibits why acid should always be added to water and not the other way around. What if we added concentrated hydrogen peroxide to the concentrated sulfuric acid instead? This is the 95% concentrated hydrogen peroxide we prepared in a previous video via vacuum distillation. Adding the hydrogen peroxide results in the formation of very powerful peroxymonosulfuric acid, which is also known as piranha solution. The IR exhibits how hot the solution is. As a side note, the test tube was facing away from me in case concentrated acid was splashed out. Well, we certainly wouldn't want to waste this piranha solution. Peroxymonosulfuric acid is a strong enough oxidizing agent that it will oxidize organic compounds to carbon and then oxidize the carbon to carbon dioxide. Thus, it quickly annihilates this stick. What a great exothermic reaction. What about dumping some sulfur trioxide on a chunk of hot dog? Well, I certainly wouldn't want that to be my finger. Those large plumes of sulfuric acid vapor also definitely warrant the use of a gas mask and goggles. Anyhow, there are a few fun reactions examined under infrared light. I hope you guys enjoyed, and I'll see you in a future project. Okay, bye.